So if I declare a variable, and we're going to go into all these declarations this week. If I declare a variable like this, what does that say and what does that do? If I do the following thing, int x, tell me what that means. Question, answer? X is an integer. What's an integer? Whole number. Now what happens when I declare a variable? Okay, you're going to learn, whenever I say that, you're going to say space is declared in memory, or space is allocated in memory. Space is allocated. So let's repeat the question. What happens when I declare a variable? Space is allocated in memory. So what happens here is I've got x, I've got some amount of space, which we're going to look at tomorrow, probably 32 bits, probably 32 bits. And what happens if I now say x equals 7? You know more now than you did at the beginning of class. So when I say x equals 7, what is happening in memory? No, that's declared. Hold that thought. Okay? What happens when I assign the value 7 to memory? V? Okay, but like this? 7's being stored, but that number is a what kind of number? That is? Well, that's a decimal. And the computer doesn't understand decimal. So what would actually be being stored there? We really know now. What's being stored? Yes. 1, 1, 1, and a whole bunch of zeros is being stored in memory. Okay? So what happens if the numbers get really big? What happens if the numbers get really big? Okay, so what do you think the largest number? Let's go back to my handy-dandy calculator. And this is one of the exercises you'll be working on soon. Shoot. What do you think the largest number that I can put in to this space is? Okay, and can you be more specific? 32 ones, right? Agreed? Hopefully that was right. And that is approximately, is that 400? Let's see. It's 967,000. So it's 4 billion. 4 billion. So what do you think about that number? What does that number make you think? It's a lot. Is it always a lot? Is it always enough? Not unless you do something. By default, if you declare a number to be integer, it's going to allocate what the storage is for that particular default, which I believe for our Visual Studio will be 32 bits. Okay? Is 4 billion always going to be enough? Can you think of a number where 4 billion might not be enough? What's that? No, well, no, I mean a number. I meant an application. Like, if I was doing population at Towson, that number's plenty. Agreed? If I'm doing population in Maryland, I'm still okay. What about the world population? I'm not going to have enough space. And what's going to happen, it would actually wrap around and actually be a vulnerability as far as a security vulnerability would go. And you're going to learn about that in lab. Okay? But I want to go one more thing. What about if I say x equals -7? We see how 7 is stored. How is -7 stored? Ideas? Well, then how would the computer know whether it was a legitimate number? Not a bad idea, but how would the computer know whether it was a legitimate number or backward? You know what I mean? Question? I like that. It does exactly what you said. Because most integers are signed, meaning what? What do I mean when I say most integers are signed? They can be what? Positive or negative, right? So if I want to be able to have positive or negative, I use one of these bits as a sign bit. If it's on, it's positive, whatever the indicator is. Okay? I think if it's 1, it's negative. Don't bet my life on that. But anyway, this is an indicator. The rest of the number works the same way binary. But hold on, what did I just do to that 4 billion? My largest number. What did I just do to that? I shrunk. I divided it by a power of 2 because I just lost, if I have to divide that by 2, and it's going to be actually a smaller number. So in reality, you don't really get all 32 bits. You get 31 bits, and you only have that amount of number to store an integer. For most of your calculations, you can live a happy life. You're fine. But however, if you have some type of application such as world population or number of Google searches in a day, probably this number is not going to be large enough. You're going to have to think about other types.